Hey, so welcome to Landscape Setup and Scaling. What we're going to be doing in this video is looking at the impact of scale on our landscapes and eventually building ourselves a 1 by 1 kilometer terrain like this that's going to have detail down to the half-meter scale in it, and the lighting will be built so that it looks clean like this, and we'll be making sure that we can preview at a reasonable performance, including using something called a light mass importance volume, which you can see in the middle here, which is just a little hack to get the lighting to build faster. So let's dive in and talk about terrain scale. So we really want to think about the scale of the landscape now. So I'm going to demonstrate a few things with some dramatic different scales so you can see the effect, and then I'll put you into a challenge where you can generate your landscape. So just watch along for now and I'll explain my thinking. So what's going on? What are we seeing on the screen? We're seeing little squares. Now these little squares are called quads. They're quads because they have 4 vertices. And they happen to be squares at this point, although as soon as we start deforming the terrain, they actually deviate from squares. We'll see that in a moment. The scale relates to the size of those squares. If I made that 1,000 in the x, it will automatically change the y, by the way, because it wants to keep the quads square rather than long rectangles. Now the terrain is 10 times larger. So what this is saying to us is we have a section size of 63 by 63 quads. So if I was to turn that down to 7 by 7, you could see it. There's 7 by 7 in each section. Okay, a section is also known as a component. So the component, there are 8 by 8 components at the moment, just like a chessboard if you look along. The large squares, there's 8 by 8 of them. So there's 64 large squares, each of which has 49 or 7 by 7 inside. So how big is the terrain overall? Well, the scale is what sets that. Again, if I set that down to 100, it gets 10 times smaller. At 1,000, it gets 10 times larger. At 1,000, we're saying it's 1,000 centimeters per quad. So it is 10 meters per quad. All right, now you don't have to do the calculation yourself. The 7 by 7 or the 7 by 8 is 57 here. There's an off by 1 error, but it's close enough. So it's 57 by 57 squares, each square of which is 10 meters or 1,000 centimeters. So it's 570 by 570 meters, this terrain. Let's try creating it at this scale and see what the impact is. So I'm going to create it at this scale. I'm then going to just do some stuff with a brush. Okay, then we're going to just go into the world by playing and have a look. Now, these squares on the floor are 10 by 10 meters, 33 by 33 feet. And that is the maximum resolution to which we can adjust the terrain. So if we look around very closely, by the way, these strange effects we get in between the big lines, they're just the fact the lighting hasn't been built. So if we look, these are the quads. You can see them here. What it is when it's deformed is it is 4 vertices. Let me just go to a different tool. You can see in the square in front of me that there's 4 vertices, but they're bent in the middle. So it's 2 triangles. Basically, a quad is 2 triangles, and that's how it meshes them all together. Now, if we were 10 by 10 size blocks, then it gives a very jagged outlook to all of the terrain, because the maximum or the minimum size at which we can adjust anything is these 10 by 10 blocks. The most that we can do is kind of pull up the middle of one of these 10 by 10 blocks to create a sharp effect like you see in some of these quads, if you know what you're looking for. Here, a lot of them are flat, called planar quads, like here, these guys are flat, and then these quads here are bent down the middle. It's a little bit tricky to see, but if you look closely, you'll see that they're 2 triangles butted up against each other. All right, so that's one extreme. I'm going to delete that landscape. The disadvantage of that is we can't quite get enough detail in our landscape, and our hill outlines look very jagged. So let's go right down to another extreme and just say, well, how about we had 10 centimeter quads? What's the problem with that? Well, one of the problems with that is that your landscape ends up very, very small, and you need a lot of sections and a lot of quads per section to even get a reasonable sized landscape. Now we have a landscape which has an overall resolution of about 2,000 by 2,000. 2,000 by 2,000 what? 10 centimeter blocks. So it's 200 by 200 meters only. Now let's create it. Sculpt it a little bit with a much smaller tool this time because it's related to the size of these quads. Getting really fast action on this now. You can kind of see that this is not exactly the scale that the tool is set up for. Now if I go in and have a look at it, what we see is, look at this amount of detail though. It's huge because each of these little squares is only 10 by 10 centimeters. It's almost too much, almost getting artifacts and noise from it. Now the advantage is massively more detail. Look how smooth the hill outlines are. The disadvantage is you're actually going to hit a maximum terrain size like this. Let me show you. If we delete the landscape And let's go back and say, okay, we're going to mandate a 10 by 10 centimeter, and we're going to hit fill world. How big does it get? Well, it's already as big as it can get. The maximum number of components we can have is 32 by 32. Okay, so that's what fill world does. It just maximizes the number of components. You could turn the selection size up in quads, and that would make the world effectively larger until you get to that 8196 by 8196 maximum. Okay, but that's 8,000 by 8,000 10 centimeter blocks, so only 800 by 800 meters. It's not even a kilometer square, and we've hit Unreal's maximum. So this is one of the principal reasons you don't want to use such a small tile size, is you're not going to be able to make a reasonably large city scale terrain like that. So just before I challenge you to create a terrain of a specific size, I just want to show you a handy trick, which is of course that you could place in the scene a cube, for example. Now if we just drop that in the scene, set it to the origin, go look at it, and then say to ourselves, well, how big is this cube? Well, they are 1 by 1 meter as standard, 100 by 100 centimeters. So if I scale this cube to say 1,000 on the x-axis, and maybe 10 meters wide, then we have a kilometer long cube. I could zoom out to see that. And back at the landscape creation tool, you can still see this cube if I zoom out. Remember that when you're holding, when you're trying to move around in the WSAD regime while holding the right mouse button, you can use the mouse wheel to change the speed that you move. So rolling the mouse wheel up or down will change your movement speed. So here we see this 1 kilometer by 10 meter long rod. And then we can corroborate that with the fact that the landscape is 8,000 by 8,000 10 by 10 centimeter blocks. So the landscape 800 meters and the rod is 1,000. So that looks about right. Okay, so that's quite a cool way of helping you scale. All right, your challenge. The way that you'll bring all this together and really understand how the scale relates to the overall resolution, etc., is by trying to get a specific landscape to a specific spec that I'm going to give you. So I want you to create your own landscape. Make it about 1,000 meters square. I say about because we're dealing with powers of 2 here. Make each quad ½ a meter in size. We're going to go for a compromise, a little bit more detail than we would have at a 1 meter size. Use 8 by 8, that is 64 components, like a chessboard. And go ahead and see if you can make the terrain of those specifications right now. Okay, welcome back. So let's take a look. So we're going for 1,000 meters in ½ meter quads with an 8 by 8. Okay, so we can set the 8 by 8 straight away. So we're constraining ourselves to that. We want 50 centimeter quads. So there you go. You might ask, what do you do about the Z scale? It's not super important. It doesn't change the way that the terrain sculpting tools work. So you can leave the Z scale at the default if you wish. Right, so now how big is this terrain? Well, we want a kilometer. It's actually the right size right now because we've got 2,000 things of ½ a meter. So that is a kilometer by a kilometer. Remember that you can look at this rod. Now the rod is still here, but it is a little bit hidden. So if I just, well, I could just drop the terrain down. There you go. You can see it's about a kilometer now. All right, so you want to leave your terrain with those settings that I've got on the screen there. You're going to end up needing a section size of 255 by 255 quads. One section per component is fine. That's a further optimization we don't need to worry about for the moment to do with how the level of detail handling works. And let's just create that terrain. Great, so we have a terrain now. I'm going to delete my funny rod measuring tool thing, cube it's called. Don't need it. This weird effect we're getting here is a lighting effect. And you may right now, depending on your machine, be having performance issues. So let me just show you something. If you go to settings, and then you can come down here to engine scalability settings. And if you're having performance issues, you can choose low or medium or high, epic or auto. Auto may work for you. And that will determine what this ends up looking like and how fast your editor operates. All right, so bear that in mind. Now these issues here will go away if we do a lighting build. So we want the lighting quality to be just down at preview for now. And if we build the lighting, it's going to take away these funny issues between the sections once it's finished. But I suspect that building this lighting may give us a warning that we've got too large a scene to be doing what they call indirect or bounce lighting on without something called a light mass volume, which you may have come across if you've been exploring volumes here. Something called a light mass importance volume there. So we may get a warning in a moment that we need to use a light mass importance volume, because otherwise it's trying to do indirect or bounce lighting over such a large area that lighting building is going to take forever. And it actually turns out that we don't really need bounce lighting across our entire scene. We could arguably turn it off entirely or put just a very small importance volume, which will mean that only a tiny part of our scene actually has very detailed bounce lighting. Let me show you their webpage while my lighting builds. You can read about it here just by clicking. I'll show you where I clicked. You go to Modes, Place, Volumes, Light Mass Importance, and click the question mark. And that will come down here and show you that typically you may have a massive terrain like they show around the outside, the grid, but only a tiny scene where the lighting needs to be calculated fully and properly. So we could do that. One way to speed up our building time would be to just cancel the light building. It actually is saying this, no importance volume is found, the scene's massive, yada yada. We could, for the moment, just in the middle of our scene, just reset the position of it, pop a light mass importance volume there, just a tiny one. Then you'll find that when you go to build the lighting, that the whole process of building the lighting will be a lot quicker, because it's saying, well, I'm going to ignore indirect light bounces beyond 1 anywhere apart from in this tiny little volume. And it may not look like it's quicker at first, but I think you'll find that it'll quickly whip through. Remember before I was chatting away for probably a minute and it only got to 50% on my machine. This time I suspect it'll be a lot quicker than that once it gets going. So a couple of tips on speed optimization for you here if your machine's struggling with these larger terrains. Remember, our goal here is to try and make a city scale terrain, and so we are pushing a little bit. That's quite a large area to be playing in, but it's perfectly appropriate for a tank game. So that's what we want to be doing. So we're coming to the end of the lighting build now. It actually still took quite a while, but you'll see that all the components or sections have now disappeared, and it's one homogeneous terrain, and I can now wander around on it, and it looks fine. You shouldn't find that where you've put that light mass volume is going to create any significant differences. We'll worry about further terrain optimization later. What I'd like you to do is just share with us whether this terrain is giving you reasonable performance. One more objective way to do that is to go to the top of your viewport and click Show FPS and play the game. So you can see that here, my 1 by 1 kilometer unmodified terrain is holding 120 frames a second. I'll be interested to hear what your frame rates are at this stage. Please post that in the questions, and I will see you soon.